Hey makers, welcome back to Hub360 Embedded Sphere, your go-to hub for Arduino tutorials, embedded system and practical electronics projects. Today we are comparing two popular temperature and humidity sensors used in Arduino projects, the DHT11, which many beginners start with, and the SHT3X, a more advanced and highly accurate sensor. By the end of this video, you clearly understand the differences, see them working side by side, and know exactly which one is right for your project. Let's dive in. Now let's meet the sensor. Let's start by meeting our containers. First up is the DHT11. This is a budget-friendly beginner-level sensor that has been around for a long time. It measures temperature from 0 to 50 degrees Celsius, humidity from 20% to 90%, and accuracy of about plus minus 2 degrees Celsius for temperature and plus minus 5% for humidity. It uses a single wired digital protocol, which makes it very easy to use, perfect for learning. Now let's look at the SHT3X family, which includes the SHT30, the SHT31, and the SHT35. This sensor is a serious upgrade. It offers temperature range from about minus 40 degrees Celsius to 125 degrees Celsius, and a humidity range from 0% to 100%. Much higher accuracy and then faster response time, better long-term stability. Unlike the DHT11, the SHT3X communicates using I2C, allowing multiple sensors on the same bus. So let's talk about the properties of the DHT11. The internal properties: a capacitive humidity sensing element, a thermistor for temperature, and a small internal 8-bit microcontroller. This microcontroller converts the analog sensor signals into digital data, which is why the DHT11 outputs digital values directly. The communication protocol DHT11 uses is single wire proprietary protocol. And here is how it works. The Arduino sends a start signal. The DHT11 responds with a 40-bit data stream. This data includes humidity integer, humidity decimal, usually 0, temperature integer, and temperature decimal, usually 0 as well. A checksum for error detection. Because this protocol relies heavily on precise timing, the DHT11 is slow, it can miss reading, and it blocks the CPU during communication. This is why DHT11 readings are usually limited to once every 1 to 2 seconds. Now let's talk about the SHT3X internal properties. Now let's look at it. It has a CMOS sense humidity sensor, a band gap temperature sensor, a 16-bit ADC analog to digital converter, and built-in calibration and linearization. Each SHT3X sensor is factory calibrated, which is why the readings are more accurate, more stable, and repeatable over long periods. Okay, the communication protocol the SH3X uses is the I2C communication protocol, a standard 2-wire protocol, which uses SDA for data and SCL for clock. Key advantage of I2C is it has multiple devices, can share multiple devices on the same bus. Each device has a unique address, and then communication is non-blocking and efficient. Okay, now the components we use in this project is 2 Arduino Nano, a DHT11 sensor, an SHT3X sensor module, breadboard, jumper wires, a 10K resistor, and USB cable. Now let's wire things up. Let's wire up the DHT11 sensor first. This is very straightforward. We connect the VCC of the DHT11 to 5 voltage. Then we connect the data pin of the DHT11 to D2 on the Arduino Nano. Then connect the GND or the DHT11 sensor to GND on Arduino net. And we add a 10K pull-up resistor between data and VCC pin on the DHT11. Now we add a 10K pull-up resistor between data pin and VCC pin of the DHT11 sensor. Some DHT11 modules already include the resistor, so always check your board first before making connections. Now let's wire the SHT3X, which uses I2C, to the Arduino Nano. First, we start by connecting the VCC pin on the sensor to the 5 voltage pin on the Arduino Nano. Next, we connect the GND to the GND of the Nano. Next, we connect the SCL pin to A5 on the Arduino Nano. Then connect the SDA pin to A4 on the Arduino Nano. No external pull-up resistors are needed. The Arduino already has them. To get the code, you will open your Arduino IDE. Make sure to download other full unified sensor library and the DHT sensor library before you head to File and click. Then look for the option that says Examples and click. Then go ahead and look for the option that says DHT sensor library. And click. Then finally click on the DHT tester. And wait for the Arduino sketch to open. Then go ahead and uncomment DHT11. Since that is what we are using. Then comment DHT22. And upload. Make sure to select your board, which is Arduino Nano, and select the correct COM port before uploading. To get the code for the SHT3X, we open the Arduino IDE and go to File. Then click on Examples. Then head to Adafruit SH31 library. Under Examples. In order to see the Adafruit SH31 library, you have to first download it if you haven't. Then click on SH31 test and wait for the sketch to open. Then go ahead and upload it. Don't forget to select your board and COM ports before uploading. Alright, let's do the side-by-side test. Here's where things get interesting. Both sensors are connected to an Arduino Nano each, and you can already see the difference. The SHT3X shows more decimal precision, and also the readings are more stable. Now let me bring a soldering iron near both sensors. Notice how the SHT3X responds almost instantly, while the DHT11 takes longer to catch up. This is the DHT11 and the SHT3X. And that wraps it up. Today we compared the DHT11 and SHT3X, wired them to an Arduino Nano, and saw the real world performance difference. The DHT11 is great for beginners, but when precision and reliability matter, the SHT3X is the clean winner. All the code is linked in the description below. If you're enjoying this tutorial, like, subscribe and share. Drop a comment if you want more sensor comparison. Thanks for watching and happy making.